FastMCP2 employs dependency injection with async context managers to handle resource lifecycle, ensuring proper acquisition and release of external connections. This pattern abstracts resource management from business logic while maintaining clean function signatures. We're about to examine how an async context manager wraps database operations, with FastMCP's depends injecting the managed connection into tool functions. The setup demonstrates resource isolation through context protocols and automatic cleanup via the finally block.
From ContextLib import Async Context Manager. From FastMCP, import FastMCP. From FastMCP dependencies, import depends. MCP equals FastMCP resource DAM. Add Async Context Manager. Async def get database. DB equals await connect to database. Try. Yield DB. Finally, await DB close. At MCP tool. Async def query user skull. SDR DB equals depends get database list. Return await DB execute skull.
This code demonstrates resource management in FastMCP using async context managers, specifically for database connections. The Get Database Async Context Manager handles the complete lifecycle of a database connection, establishing it before use and ensuring proper cleanup afterward, even if errors occur. This pattern is crucial for preventing resource leaks in asynchronous applications. The query user's tool leverages FastMCP's dependency injection system through depends.get database to automatically manage the database connection. When the tool executes, FastMCP resolves the dependency by calling the context manager, providing the active connection to the tool, and handling cleanup after execution. This approach separates resource management concerns from business logic while maintaining clean function signatures. Using context managers for resource management provides several advantages. It ensures deterministic cleanup, handles exceptions gracefully, and integrates seamlessly with FastMCP's dependency injection system. The pattern is particularly valuable for expensive resources like database connections, as it prevents leaks while keeping the tool interface simple. Clients only see the SQL parameter, not the underlying resource management. Let's break it down.
From ContextLib import Async Context Manager.
Imports the Async Context Manager decorator from the ContextLib module, which enables creating asynchronous context managers using generator functions.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which provides the core functionality for creating Model Context Protocol (MCP) servers. This import enables the creation of FastMCP server instances in the codebase.
From FastMCP dependencies, import depends.
Imports the depends class from the FastMCP dependencies module, which is used for declaring dependencies in FastMCP tools and resources.
MCP equals FastMCP resource DAM.
Creates an instance of FastMCP with the server identifier resource demo. This string serves as a label for the server that will appear in MCP protocol handshakes to help clients identify it, but doesn't configure any functional behavior. The MCP variable now holds this initialized FastMCP object.
Add Async Context Manager. Async def get database.
Defines an asynchronous context manager function named getDatabase using the @Async Context Manager decorator. This function will manage the setup and teardown of a database connection when used in an async with block, handling the asynchronous entry and exit operations automatically.
DB equals await connect to database.
Asynchronously connects to a database and assigns the resulting connection object to the variable db. The await keyword indicates this is an asynchronous operation that will pause execution until the database connection is established.
Yield DB.
Yields the database connection object db to the caller, allowing it to be used in the current execution context. This is typically used in generator functions to provide the database handle to the consuming code while maintaining control over its lifecycle.
Await DB close.
Asynchronously closes the database connection referenced by the db object. The await keyword indicates this is an asynchronous operation that will suspend execution until the database connection is fully closed. This ensures proper cleanup of database resources and prevents connection leaks.
At MCP tool. Async def query user skull. SDR db equals depends get database list.
Defines an asynchronous function named query users decorated with @MCP tool, making it available as an MCP tool. The function takes a SQL query string as input and an optional database dependency that defaults to the result of getDatabase. It returns a list, indicating it will execute the SQL query and return the results as a list of records.
Return await DB. Execute SQL.
Executes a database query asynchronously by awaiting the result of db, execute with the provided SQL statement. The await keyword indicates this is part of an async function, pausing execution until the database operation completes and returning the query result. FastMCP 2 elegantly combines async context managers with dependency injection to handle resource lifecycle while keeping business logic clean. The getDatabase context manager encapsulates connection setup and teardown, using yield to provide the active connection and finally to guarantee cleanup. This pattern ensures deterministic resource management, even with exceptions. The query user's tool then leverages FastMCP's depends to automatically inject the managed database connection. When invoked, FastMCP resolves the dependency by calling the context manager, providing the connection, and handling cleanup afterward. This separation of concerns means tools focus purely on business logic, while resource management remains transparent to callers. The key insight here is how these patterns work together. Context managers provide the lifecycle guarantees, while dependency injection makes those managed resources seamlessly available to tools. The result is robust resource handling without cluttering tool interfaces or requiring manual cleanup. This approach scales particularly well for expensive resources like database connections, preventing leaks while maintaining clean, maintainable code.
The database appears, answers, and disappears, yet the numbers linger, as if they were never asked.